So today we'll be talking about adding and subtracting radicals. We're going to have a few notes that we'll fill out along the way just to make sure we're good with this. So starting up here at the top of our notes, you should have your page glued into your notebook already. So what we're going to do is we're going to start up at the top where it says you can only combine. All right. So underneath that it says you can only combine. We want to write in like radicals. And what I mean by like radicals is like if I have 3 on the square root of 2, an example of a like radical would be like, say, -2 on the square root of 2. All right? When we have like radicals, we're looking at this being the same. Okay, that's what it means by like. So when we have like radicals, we're looking for the radical and the number underneath the radical, which is the radicand, to be the same. In that next line, you're going to write in the word like radicals. Like radicals have the same index and the same radicand. And we talked about those two definitions earlier in the week. We said that an index is going to be the number that's understood to be out here, which here in this case would be the square root, or the index would be 2 because we have a square root. So like I said, with this, we know the index is going to be the number that's understood to be in front of the exponent. Don't get in front of the square root or the radical symbol. Don't get that confused with these two numbers, which would be coefficients, okay? So that would be your index, and then the number that's inside, which is the 2's here, those two numbers would be the radicand. So we have to have the index and the radicand being the same in order to have like radicals. Now, in this little box right here, we want to write down the most important rule, kind of the golden rule here for adding and subtracting radicals, and that is to simplify. Simplify everything first. I may run out of room here. Everything first. We'll just extend that little box on that. Alright, so simplify everything first. We want to make sure that before we do anything with adding and subtracting radicals, we want to make sure everything is simplified to its simplest form before we combine those numbers. So make sure you simplify everything first. That's always the first step in adding and subtracting radicals. Now, underneath that it says to combine like radicals. So to combine like radicals, we want to add the coefficients and keep the same radical. So to combine like radicals, we want to add the coefficients together. Remember, the coefficients are going to be the numbers out here on the outside of the radical. And then we want to keep the same radical, meaning that these two things we have circled here, we want to keep those the same when we combine radicals. All right, so with that being said, we want to look real quick at an example. We'll come over here to the side and we'll do our radical. Let's just erase a little bit of this. So we'll erase everything on this side so we can work it out. But let's look at our two examples as to how to combine like terms here. So the two examples they have down there at the bottom of your page, the first one they have is 2 on the square root of 45, and then they have minus 2 on the square root of 5. Now currently the way these two are set up, we cannot combine the 45 and the 5 because are these the same? No, the 45 and the 5 are not the same. So what we have to do is we have to see if we can simplify something down here. So let's start with our 45. So is there a way for me to break this 45 down into two things? Yes, what numbers? All right, 5 and 9. Okay, so we can break that down into 5 and 9. So just like yesterday, we said that we want to ask the question, can we break it down any further? So can 5 break down any further? No. So if it can't, we circle it. What about 9? Yes, 9 breaks down into what? 3, and 3. Will the 3's break down any further? No. So if it's no, circle it. So what I have here is I basically have, first I had a 2 on the outside. So I'm going to bring that 2 on the outside. I have a pair of 3's. So since I have a pair of 3's, I'm going to put a 3 on the outside. And then I have a 5 left over, which means that's going to go inside the radical. Now, over here, will this 5 on this side break down any? No. So we know it's already in its simplest form. So we can write minus 2 on the square root of 5. Alright, so to work this problem out, we want to make sure we finish it out. Right now, everything's the same, but we got some simplifying we can do on this side. So what we have to do is we have to take the 2 times 3 and multiply it to get what? So that's going to be 6 on the square root of 5 minus 2 on the square root of 5. So to finish this problem out, now if we look, we see that our radicals are the same. So if those radicals are the same, we just basically add or subtract the 2 numbers in front, the coefficients. So here, what would be 6 minus 2? 4. So we get 4 on the square root of 5. And that would be the final answer. Alright, so that took care of that example. Real quick, I want to look at example 2, and then I'm going to let you guys do some practice problems. Example 2 is a little bit more involved, though. In this one, we have negative 3 on the square root of 12 plus 3 on the square root of 3 plus 3 on the square root of 20. Now notice, here every single radical is different. We have one radical that's going to be square root of 12, we have one that's the square root of 3, and we have one that's the square root of 20. So all 3 of these different radicals are extremely different in that aspect. So what we've got to do is we need to break these down to their simplest form, and then we can look at adding or subtracting them to get our answers. So let's start with this 12. So with the number 12, what do we know 12 can break down into?
6 and 2.
All right, 6 and 2, 3 and 4. We could use any of those, right? Let's use 3 and 4 for this one. So we're going to use the numbers 3 and 4. Will 3 break down any further? No, so we circle it. What will 4 break down into?
2 and 2.
2 and 2. Will the 2's break down any further? No, so circle those. So what we have here is we have a negative 3 on the outside, so we're going to write negative 3 times, we had a pair of 2's that go on the outside, so that's going to be a 2 on the outside. And then if you notice, we had a 3 left over, so that's going to be on the square root of 3. Now, we'll come back and do the multiplication for that in a second. Let's move to the second one. 3 on the square root of 3. Can we break down the square root of 3? No. So if we can't break that down, then it stays the way it is. Plus 3 on the square root of 3. And then lastly over here, we have 3 on the square root of 20. So we can break this 20 down. What will 20 break down into?
10 and 2.
All right. Let's do 4 and 5. So, would 4 break down? Yes, 4 breaks down into what?
2 and 2.
2 and 2. 2's don't break down, so we circle them. What about the 5? No. So if it doesn't, then we circle it. So in this problem, we have a 3 located on the outside, so that's going to be a positive 3 times, we had a pair of 2's, so that's going to be a 2 on the outside, and we had a 5 left over, meaning it stays inside the radical, so we write the 5 inside the radical. Alright, so far we just broke everything down. Now we need to multiply what needs to be multiplied, and then we can do our addition and subtraction. So looking back over here on this first one, we had negative 3 times 2. So what's negative 3 times 2? Negative 6, and that's negative 6 on the square root of 3. Next, we just had 3 on the square root of 3. That has no simplifying needed, so we can just write plus 3 on the square root of 3. And then the last one over here, we had 3 times 2. So what's 3 times 2? So we got plus 6 on the square root of 5. Alright, now all that's left to do is combine our like terms or combine our like radicals. So here, what are our 2 like radicals? Negative 6 and what? 3. We notice that these are like radicals because of the radical here. We know that those 2 things are the same. We have the square root of 3 and the square root of 3. Over here, this 5 isn't the like those because it has a 5 instead of these 3's. So that means that that one's not going to combine with anything. It's going to stay by itself. So looking at these 2 that we have here, what's going to be negative 6 plus 3? right? Negative 3, and that's going to be negative 3 on the square root of 3, because when we combine them, the radicals stay the same, right? We do not change those radicals. And then we have 6 on the square root of 5 over here, so since that has nothing to add to it, we just keep it plus 6 on the square root of 5. Now, since those don't combine, we have an expression as our answer, so that entire thing would be what we would call our answer for this problem. So, like I said, those would give you the examples for these two problems. Make sure you write those down. And if you have any questions, please let me know.